Sallee, and this is my demo for my group's final Python project. So to start, here is my MAC address on my computer, and this aligns with the one that was turned into our user documentation or our user manual. So there's that. Then let's get rid of this text file. So I'm going to start off by showing our command line version, because that was the version we were able to get working best. We had some issues with our graphic user interface. So when I run the game, we start off with a main menu, and we have options to play. Player versus player, easy or AI, easy AI. The reason these are easier and easy was because we had planned to have some more difficult AIs using Minimax, but it looks like that is not going to get completed in entirety. So if I play player versus player, I can go, and then the next person goes. Quit. I can also do the AI. I'm going to do 3-5 again. The AI is thinking, and then places their token. So we have a game logger. So all of the output that goes to the terminal, the serial output is put into a text file, and the text file is the day's date. So I played today on April 26th. If I play tomorrow, I would get a new file that would be April 27th. And it shows everything that I just did. Alright, so now this is our graphic user interface that isn't quite functioning right. Okay, so I can either quit or start game. We have player versus player, player versus computer, how to play. Computer was going to have a difficulty, and this would have been like easier AI, easy AI, and then the Minimax if we had gotten that working. So this is our how to play. I'll just give some quick directions on the game. And then here's our actual game board. We got our scores in the bottoms. So if I play there, this is player versus player. We can quit to main menu, we can quit, and we can press quit to end the game. Alright, so as far as the code goes, the way that we started, or the way that I started, was I first created all of our frames in the actual GUI for the game, and then realized that it was kind of more important to get the game up and running. So after that, we decided to just get the command line working and get a playable game, and then we could put GUI on top of it. So we thought that would be a good idea, but then it turned out to be actually pretty difficult to integrate the GUI on top of the already running game. So we should have done them in parallel. But in our othello.py file, I followed a tutorial, and I created classes based on subclasses from the tkinter. So I use that as the master class. And so when we initiate here in our constructor, this creates all the frames that are in the page. So we have start page, main menu, directions, player versus player, and player versus CPU. It puts all these frames in a container and then creates a grid for them. And then we have another function called show frame. So when we press the buttons to move to different screens, it calls the show frame function to pull up a new frame. And then all the pages are pretty much similar. They just have a constructor. So we have the start page with the constructor, and it really just sets up the page. It puts the label header at the top, some buttons. Again, here we have the show frame. So when you press that button, it shows the main menu page. Configuring the buttons just to have black around the outside of it, make the background of the button white, and set the state to normal. And then we can use the pack to actually put it on the screen, and this puts 50 pixels of padding on the y-axis, so above and below the button there's 50 pixels of padding. These are really the same. The main menu's just the same deal, just with different buttons, more buttons. And I did all of these. I made the Reversi app, the start page, the main menu. I had initially created the player versus player, but then Michael came in when he was working on getting the GUI to actually play in the game, and he kind of recreated it. We got a whole bunch of different functions in here that Michael worked on. I added this show header, so when you're actually playing the game at the top, it'll show the header of the game. And then player versus CPU puts a slider on the screen and does the same thing with the header and the buttons. And then down here we have the app actually running. So we create a global app. App is the Reversi app. We set the screen sizes and then initiate the main loop. So this interacts with our reversi.py, which was created from our console version. We just kept the console version, made a copy, so the console version was its own working standalone, and then the reversi.py was meant to work with the GUI. We just wanted to have a backup so we didn't lose anything. So we have our modules up here. We use deep copy, date time, random, and system. Deep copy is for the board, so we can, when a player makes a move, we want to copy the board, and that way we won't apply false moves while checking for the valid moves to the real board, because then we'll screw the game board up. And then we have date time, and that's for the text file to get the current date. Random is for the random AIs, or the random AI, and then system is also for the file logging system. So what I created in the Reversi Python file, these are going to be pretty much the same between Reversi PY and console version PY. Is I created the board class, I created the player class, I created the human player class, the random AI player class, the max tokens class. I created the Reversi app class in the console version, and then Michael and you created a Reversi app 1 to work on in the GUI version. I created all of these exceptions, but they work with the console version. We didn't need them in this version. I created the logger and the functions in it, and then the main menu is commented out here because we don't need the main menu when playing on the GUI because we already have a main menu created with tkinter. So I'm going to go to Reversi console just because it has everything and I can go a little bit more in depth. So I created the board class, and when it's constructed, it generates a board. So it calls the generate board function. This function creates a list and then loops through that list. So for each row in the list, it creates another list. So it's a list of lists because there are no two-dimensional arrays in Python. And then we place the beginning tokens, so 1, 2, 2, 1, because those are the tokens that you start off with in the middle at the beginning of a game, right here. 1, 2, 2, 1. So print board, we need to convert the board to a string to actually print it out. It was different for the Reversi Python, but Michael did that one. So we convert to a string by creating our headers so we can see the grids, and then we loop through the board and check to see if we're at the end of the board, and if we are, then we have a new line. Otherwise, we keep printing the tokens out. Mohammed did the get score function. I worked on place token, so we have an error to make sure that the correct player is playing, and then also make sure that where they're playing is inbounds. And then, so this function receives the x and y where they want to play, and it calls isValidMove to get the tokens to flip. So isValidMove will check if it's a valid move, and if it is not a valid move, it will return false. If it is a valid move, it will return the tokens that are flipped from that move. So again, if tokens flipped is false, you can't place the tokens, so this function will return false. Else, it'll call flip tokens to actually flip the tokens and return true. Flip tokens is pretty basic. I wrote this as well. It just takes the x and y, sets it equal to player, and then loops for all x and y in tokens to flip, and changes those tokens. So isValidMove, we check if the actual spot on the board is not equal to 0, and then we also check to see that the move is on the board. We set the tile on the board, and then check to see who's playing. So if the player is 1, then the other tiles should be 2. Otherwise, it's player 2 playing, so the other tiles should be 1. And then we create our list of tokens to flip. So what this for loop does is we have an iterator for each direction. So this would be up 1. This would be diagonally 1. This is left 1, diagonally down left, and so on. So we set up x and y as to where they originally play, and then we increment to check all the way up, all the way diagonally to the right, all the way to the right, all diagonally to the bottom left, or bottom right, all the way down, and so basically every single direction on the board. And we continuously check that these tokens are on the board. Then we also check if it's the other tile. If it's not on the board, we'll break and we'll go to a new direction. If it is on the board, we continue. And then if we reach the point where this is if we reach the point where there are pieces to flip over and we get to the end and have found that we've ended up at that player's token, meaning that all the pieces are bounded by 2 tokens of that player, then we know that we need to flip the tokens. So we'll add x and y to tokens to flip. So then we restore the empty space because we had initialized it because we originally put the player's piece there. We do this because this is, again, it's just a copy of the board. When this function is called, we're not actually doing anything with it. So if the length of tokens to flip is 0, we didn't find anything, so we turn false. Otherwise, we're going to return the tokens to flip. Get valid moves. I don't remember if I did this one or if Michael did this one, but I'm going to go over it anyways, I guess. So we create all the list of moves. If any valid moves are found, we initialize this to false, because if nothing's found, then it's just going to return false. And then Michael did do this one. I'm still going to finish, but Michael did do this. So we go through all rows and columns in the board, and then call isValidMove, and if isValidMove returns anything, and it's true, then we append that that move into the valid moves, and now this function will return 2. So then we return whether it was found or not, and then the moves. So is on board, I actually already showed earlier. It's pretty simple. It just checks to see if everything is within the range of the board, so 0 to 7. This is an 8x8 board. Is full is pretty simple too. We just loop through the entire board, and if anything is 0, then the board is not full. Otherwise, it is. So this is the base player class, and we have get name is human and get move. They all just return like default variables because we don't actually use the player class, we use the human player class. So the human player get name will return human, and then is human returns true, and then get move actually gets the move from the player, and it calls get move input to do it. So get move input will prompt for an input for the x and the y, and then if it's q, it allows the player to quit, and then we cast those variables to integers. And if it's an invalid move, then we call, say, invalid move, try again. The random AI is another one that I wrote that's based on the player base class, and it returns false for as human. Its name is random AI, and then when it gets move, it calls random move. Random move calls get valid moves to see if the board has any valid moves. It looks through the list of moves that's returned, and then it chooses just a random one. So random choice from set of moves is equal to move, x move 0, y move 1, and then return x and y. Max tokens AI I also wrote. We have, oh, I'm sorry, this should be max tokens. I overlooked that. Save that just for the future work on this. So it's not human, returns false. Does the same thing for getting the move. But when it actually gets the moves, it looks through all the moves inside of moves, looks for whatever one has the max tokens, so based on the length of tokens to flip, and then updates the final move if it's greater than or equal to the previous max tokens, and then it returns the final move. So again, here's our reverse C app. We have an initializer that creates the game board, creates a dictionary for the players 1 and 2. So then has valid move just checks the board and uses get valid move to see if a player has a valid move. Is game over, checks if the board is full, and checks to see that both players have valid moves. Take turn actually makes the game play, so it makes the back and forth go. Wait, no, I'm sorry. Play does that. Take turn actually copies the board right here. And then we get the move from whatever player was playing based on the dictionary. Then we place the token. And let me back up for a second. When we actually get the move, we use the copied board from right here so we don't screw up the game board. So then we place the token and then call take turn for the player because it's going to be the next person that plays. If it's invalid move, that's recursive, so it'll recall this, so player 1 plays again. And then otherwise places the token, updates the score, and then it prints out the scores. So it says like the player, whoever's playing, placed a token at these coordinates. Player 1 scores right now is P1 score, player 2 scores P2 score. Um, we had some getters that we saw in some other games, but it ended up not really needing. So we have get board, get player. Here's the play class that I was talking about. So I wrote this class as well, or sorry, this function as well. So when you actually start the game, it calls play, generates a board. While the game is not over, and if the player 1 has a valid move, player 1 takes their turn. If the game is over, game over. Then if player 2 has a valid move, player 2 takes their turn. And if the game is over, game over. So keep doing this until the game ends. So while not, game is over. And then after each move, the board is printed. But once the game is over, we want the board to print again. So once this while loop exits, we print the final game board. And then here are the classes for exceptions that I made. We have an out of turn, invalid player, out of bounds, filled space, so somebody already played in that spot, and then invalid move, it's not a valid cell. And then here's the logger class that I wrote again. We have constructor to set it up with the terminal, name the file, and then open the file. And then we write to the file, so anything that goes to the terminal, anything that happens in the game is printed to the terminal and printed to the log. And then this I just found online. It's necessary for Python 3 because you might get some weird errors if you don't have this in there. All right, let me just check to make sure that I got everything. Oh, so what we wanted to achieve, we wanted obviously to get our GUI working. It unfortunately did not. I mean, I guess we're gonna keep working on it over summer just for fun, so we can show it, to jobs and have a nice working GUI for interviewing. But yeah, we kept getting this weird indexing error. We got a lot of errors actually, but we were able to solve a lot of them with your help. But we kept getting an indexing error later on, where once we reached the end of the game, the board in the GUI wasn't able to communicate with the board generated in Reversi PY in our Reversi app. And then it started thinking that tokens were being placed off of the board, which I don't understand how that could possibly be happening, because the way that Michael set up the GUI board was every single button is a coordinate, so you shouldn't be able to press a button that's not on the board because they're all 0 through 7. So it really doesn't. It didn't make any sense. So that's going to be nice and frustrating to work on this summer, but I'm sure we'll figure it out in due time. The original plan, well, our original plan was just to create a game with a graphic interface and no AI. We ended up doing AI. I created random AI and max tokens AI, and then Sadat and Mohammed were supposed to create the Minimax, but they had a bunch of issues that they were running into getting it to integrate with our game. So they used other algorithms that they found online, but they couldn't quite tweak them to get them to work in our version of the game. We also wanted to do some cool things where we could create different tokens, like different game pieces, but then we ended up making our GUI game pieces buttons, because it was just, we thought it would be more simpler because we could just make each button a coordinate, and when you press it, that would be get move. But that obviously did not turn out as planned. So maybe over summer, what we should do is scratch the button game board and do something with T. Kinter's canvas class and create a canvas, and then update that canvas with different shapes like squares or circles or triangles, and maybe we could make different colors on them, and that way we can also have different game pieces. Alright, so that is all that I have. Thank you for the semester. This was a fun class, and I'm sorry that we weren't able to get our game fully working for you, but we did learn a lot, and it was pretty cool to work on. It was frustrating, but when we actually figured out some of the errors we were having, it was a great eureka moment. So thank you, and have a great summer.